Uh, Welcome to another video on a recap of basics of control systems. In this video, we will concentrate on modeling of mechanical systems. Okay, these are the prerequisites before you watch the video. Okay, with these prerequisites, let us start the modeling of. Okay, this is the mechanical system what we have been given to find the transfer function or to write the integral differential equation of this mechanical system. So this is a linear displacement system. It has got two masses and of course a few spring and dash path constants. So let us identify the displacements here. So this is having a displacement of x1. So let us assume that this has got a displacement of x2. Let us write the free body diagram for this particular mechanical network with acting force F in the direction shown here on mass m1. It is opposed by the force due to the mass, that is m1 into acceleration. So acceleration, of course, let me say it as a1. A1 is nothing but the acceleration which is due to the displacement, which is dx1 by dt. Okay, this is okay. Let me say it as dv1 by dt, where dv1 is the velocity. Sorry, v1 is the velocity of this, and this can be further written as d square x1 by dt square. So, because we know that velocity is displacement, rate of change of displacement. So ultimately, I can write x1 as x1, sorry, a1 as x1 double dot. So this I can write it as m1 x1 double dot. Double dot actually indicate double derivative, and this is one of the opposing force. The other opposing force is due to the spring constant, which is having a magnitude of k12. There is a relative displacement for this one, which is x1 minus x2. So these two are the opposing forces for m1 for the acting force F. So we can write what is the acting force on m2. So on m2, the acting force is due to this spring constant k12. The opposing forces are, so it is m2 x2 double dot. It is b2 x2 dot, and it is k2 x2. These are the opposing forces. We are asked to find what is x of s by f of s. So this is the transfer function what we are asked to find. So let us write f of s as equal to m1 s square x1 of s plus of k12 x1 of s minus x2 of s. This can be further written as m1 s square plus k12, this is x1 of s minus of k12 x2 of s, this is f of s. This is equation number 1. So with respect to equation number 2, it is k12 x1 of s minus x2 of s is equal to m2 s square x2 of s. You can see, and then this is b2s into x of s plus k2 into x of s. So I can bring all x of s onto one side. So I can write k12 x1 of s is equal to, so here also we have x of s, it is m2s square plus b2s plus k2 plus k12 into x to of s. Correct. So this is the equation what I have, and ultimately, so I have this. Uh, so what I want is x2 of s by f of s. So this is equation number 2, equation number 1. So from equation 1, you have f of s is equal to m1 s square plus k12 x1 of s minus of k12 x2 of s. So what you want is x2 of s and f of s, but you have x1 of s here. So use equation 2 and replace x1 of s by. So can I write x1 of s as equal to, this is from equation 2. From this equation 2, I can write x1 of s as m2 s square plus b2s plus k2 plus k12 x2 of s divided by k12. So this is my x1 of s. So what I do, I will replace this x1 of s by this quantity, So f of s now is equal to m1 square plus k12 multiplied by m2 square plus b2 of s plus k2 plus k12 by k12. Okay, because this x2 of s is there, so let me just minus of k12 whole x2 of s. So you can write finally x2 of s by f of s is equal to, can I write it as k12 whole divided by, so this k12 when it get multiplied, okay, let me just do like this and let me make this square. So now it is m1 square. Sorry, this is what I did. So this k12 was only here, so I just made this common factor, so this went up there, plus of b2s plus k2 plus k12 minus of k12 whole square into m1 square plus k1. This is the transformation. Of course, if you substitute the values of different constants of this mechanical system, you'll get a second order equation. You can see order of the equation is okay. In this way, so you can just repeat. Given a mechanical system, identify the displacements in the direction of the applied force. Applied force is going in this direction. Make sure that displacement is also in the same direction. Then write the FBD with acting force and the opposing forces. So write the equation using Newton's second law. Acting force is equal to opposing forces. So this is actually like this. Fine. So then you write, there are two equations. So since you want to have x2 of s by f of s, so try to eliminate x1 of s using equation 2. So that's what we did here. And then you can end up with a simpler simplification of this mechanical transfer function of your mechanical system. So let us take up one more such equation. So let me just take this. You have this. Let us consider. So let me just take. So this is the force. So let us assume that this is having a friction B1. Let us assume that this is got a friction B2. Let us assume that this is M1, this is force, this is B12. Let us assume this is K12, this is K2, this is B3, this is M3. So before we start writing the FPD, let us identify the displacements. So this is displacement x1. So here there is one more displacement x2. Here there is another displacement x3. There are three displacement. We can basically consider, so there is a dummy mass with m equal to 0. So this is a dummy mass with m equal to 0. Now we can write the FPD. Maybe you can write the FPD in the this way. You can write this is your F. So this is M1. The opposing forces are, this is M1 x1 double dot. Next you have B1 x1 dot. Then you have B12. This is x1 minus x2, x1 dot minus x2 dot. So this is the opposing force. And to this, so this is your mass, that dummy mass. The acting force on that is this. Whichever is the opposing force for M1 will become the acting force for this mass. This is this, and opposing force for this dummy mass is K12 into x2 minus x3. So that will become the acting force for M3. Okay, let me write it as M2. The opposing forces are, so this is the acting force. So now you can see this is opposing force. One is due to M2 x3 double dot. This is B3 x3 dot, and this is K2 x K2 x. Now let me write only the force equations. F of S is equal to M1 A square K x1 of S plus B1 S x1 of S plus B12 S x1 of S minus x2 of S. This is first equation, or the second equation. Second equation, this happens to be the acting force, which is B12 S into x1 of S minus x2 of S. That will be opposed by, because this mass is 0, I can write it as K12 x2 of S minus x3 of S. Then this is your second equation. The third equation would be K12 x2 of S minus x3 of S is equal to M2 A square plus B3S plus K2 into, because I think I didn't write this B2. Did I write B2? So let me write B2 also. This is B2 x3 dot. So this is B3S also into x3x. Correct? So this is your acting force. Opposing forces are due to friction, mass, and this B12, and this is acting on the dummy mass. Opposing force is due to K12, which happens to be the acting force for M2, and the opposing forces for M2 are the acceleration into mass, this K2, this B3, and this B2. So that's what is M2, B3, K2, and B3. So these are the equations. Suppose if you are asked to find what is x3 of S by f of S. So then you have this equation. In this equation, try to eliminate x2 by substituting this, uh, sorry, eliminate x1 by substituting this, and then eliminate x2 by substituting this value. So it's actually a double elimination you may have to do, which will be a bit lengthy process, which you can certainly do. But usually, uh, again, if it is like in the previous problem, if it is only two displacement, it is easy. If it is three displacement, the equation become very complex. Without having the values, it simply becomes substituting the values, substituting the equation from this to that, and so finally from this you will eliminate, okay, x1 from this. Ultimately you will eliminate x2 in terms of, this will be replaced in terms of x2 and x3, and this is finally displacement in terms of x3, so that you have f of s and x3 only, so that your transfer function will have some numerator and denominator in terms of zeros and ones. Zeros and, of course, we can able to certainly represent this in the matrix form, but of course it will be of much use if you are solving a design, not for just writing an equation, something like this. Okay, let us write a mechanical rotational system and try to understand its supposing that this is a mechanical rotational system having some, okay, assume that this is torque, this is b1, this is j1, this is k1. So it's a simpler one. So let us identify the displacement. Here it is theta 1, here it is theta 2. Same theta 2 will comes here. Since it is rigid, there are no more displacement. If you, now you have a dummy mass here. So where do you have, so you have a dummy mass since force is applied here. So let me write the dummy mass here. So this is, so you have a dummy mass m equals to 0. You are applying a torque here, and this certainly results in an opposing torque due to this friction, and that will act on inertia J. This is the one which is acting here, and there are opposing forces. One is due to the uh, inertia of J1 and other is due to K1. So let us write this. So what is this? This is actually you have B1 theta 1 dot minus theta 2 dot. The same thing is the acting force on this. So here it is J1 theta 2 double dot, and it is K1 theta 2. So can I write the equation? The equation is P of S is given by, the torque is given by, the opposing force is B1 S theta 1 of S minus theta 2 of S, and this will be the acting force B1 S theta 1 of S minus theta 2 of S is equal to J square, sorry, J square plus plus K1, this is theta 2 of S. So this equation ultimately comes as B1S theta 1 of S is equal to J square plus BS, so B1S into K1 theta 2 of X. So this is equation number 2. This is equation number 1. This is how we can write. So now you can see, since the torque is directly applied to what is that, dashpot, it will have a dummy mass. It will have a dummy mass. So when I say mass, in this case it is inertia. So J is equal to this. Mass and inertia are analogous from translational to rotation. Let us write one more such mechanical system. So this is this. Let us take this. Let us take this as some. Suppose it is. Let me consider there is one more dashboard here. Similar, this is star. This is A1, A2, A3, K1, B1, B2, B3. So let us I have taken simply a random equation. So this will have theta 1, this will have theta 2, this will have theta 3 as a displacement. So I can straight away write, okay, let me write the FPDs. This is J1 acting torque, the opposing torques are J1 theta 1 double dot, due to B1 it is B1 theta 1 minus theta 1 dot minus theta 2 dot, whereas K1 is theta 1 minus theta 3. So this will be the acting torque on J2, that is J2. The opposing torque is due to J2 itself theta 2 double dot, and due to B2 it is theta 2 dot minus theta 3 dot. This comes all the way here. Now this will be the acting torque on this. So this is in this direction, this is in this direction. So now this is J3, the opposing torque is J3 theta 3 double dot. This is B3 theta 3 dot, and this is K2 theta. So I can write the equation TFS is equal to J1 square theta 1 of S plus B1 is theta 1 of S minus theta 2 of S plus K1 theta 1 of S minus theta 3 of S. Correct? This is theta 3 because it is between 1 and 3. This K1 is between 1 and theta 1 and theta 3. And second equation is B1 B1 is theta 1 of S minus theta 2 of S is equal to J2 square theta 2 of S plus B2 is into theta 2 of S minus theta 3 of S. Then finally the equation is K1, it is K1 theta 1 of S minus theta 3 of S plus of B2 is theta 2 of S minus theta 3 of S equals J3 square plus B3s plus K2 to this is theta 3 of S. Correct? I'm just simply equating left hand side torque to right hand side, that is clockwise torque to anti-clockwise torque. These are clockwise torques acting torque, whereas opposing torques are in the anti-clockwise direction. So this is clockwise, this is anti-clockwise. Okay, that will, I think, hope you can able to write the free body diagram of a given mechanical system. The key is identification of the displacements of the system. So how many number of displacements are there in that given mechanical system? Thank you.